The biosphere is the global sum of all ecosystems. It can also be termed as the zone of life on Earth, a closed system, and largely self-regulating. By the most general biophysiological definition, the biosphere is the global ecological system integrating all living beings and their relationships, including their interaction with the elements of the lithosphere, geosphere, hydrosphere, and atmosphere. The biosphere is postulated to have evolved, beginning with the process of biopoiesis or biogenesis, at least some 3.5 billion years ago. The earliest evidence for life on Earth includes biogenic graphite found in 3.7 billion-year-old metasedimentary rocks from western Greenland and microbial mat fossils found in 3.48 billion-year-old sandstone from Western Australia. More recently, in 2015, remains of biotic life were found in 4.1 billion-year-old rocks in Western Australia. According to one of the researchers, if life arose relatively quickly on Earth, then it could be common in the universe. In a general sense, biospheres are any closed, self-regulating systems containing ecosystems. This includes artificial biospheres such as Biosphere 2 and Bios 3, and potentially ones on other planets or moons. Origin and use of the term. The term biosphere was coined by geologist Edward Suey in 1875, which he defined as the place on Earth's surface where life dwells. While the concept has a geological origin, it is an indication of the effect of both Charles Darwin and Matthew F. Maury on the earth sciences. The biosphere's ecological context comes from the 1920s, preceding the 1935 introduction of the term ecosystem by Sir Arthur Tansley. Vernadsky defined ecology as the science of the biosphere. It is an interdisciplinary concept for integrating astronomy, geophysics, meteorology, biogeography, evolution, geology, geochemistry, hydrology and, generally speaking, all life and earth sciences. Narrow definition geochemists define the biosphere as being the total sum of living organisms. In this sense, the biosphere is but one of four separate components of the geochemical model, the other three being lithosphere, hydrosphere, and atmosphere. The word ecosphere, coined during the 1960s, encompasses both biological and physical components of the planet. The Second International Conference on Closed Life Systems defined biospherics as the science and technology of analogues and models of Earth's biosphere, i.e., artificial Earth-like biospheres. Others may include the creation of artificial non-Earth biospheres, for example, human-centered biospheres or a native Martian biosphere, as part of the topic of biospherics. Extent of Earth's biosphere. Every part of the planet, from the polar ice caps to the equator, features life of some kind. Recent advances in microbiology have demonstrated that microbes live deep beneath the Earth's terrestrial surface, and that the total mass of microbial life in so-called uninhabitable zones may, in biomass, exceed all animal and plant life on the surface. The actual thickness of the biosphere on Earth is difficult to measure. Birds typically fly at altitudes of 650 to 1,800 meters. And fish that live deep underwater can be found down to -8,372 meters in the Puerto Rico Trench. There are more extreme examples for life on the planet. Ruppel's vulture has been found at altitudes of 11,300 meters. Bar-headed geese migrate at altitudes of at least 8,300 meters. Jacks live at elevations between 3,200 to 5,400 meters above sea level. Mountain goats live up to 3,050 meters. Herbivorous animals at these elevations depend on lichens, grasses, and herbs. Microscopic organisms live at such extremes that, taking them into consideration, the thickness of the biosphere is much greater. Culturable microbes have been found in the Earth's upper atmosphere as high as 41 kilometers. It is unlikely, however, that microbes are active at such altitudes, where temperatures and air pressure are extremely minor and ultraviolet radiation very intense. More likely, these microbes were brought into the upper atmosphere by winds or possibly volcanic eruptions. Barophilic marine microbes have been found at more than 10 kilometers depth in the Mariana Trench. In fact, single-celled life forms have been found in the deepest part of the Mariana Trench, Challenger Deep, at depths of 36,201 feet. Microbes are not limited to the air, water or the Earth's surface. Culturable thermophilic microbes have been extracted from cores drilled more than 5 kilometers into the Earth's crust in Sweden, from rocks between 65 to 75 degrees Celsius. Temperature increases with increasing depth into the Earth's crust. The rate at which the temperature increases depends on many factors, including type of crust, rock type, geographic location, etc. The greatest known temperature at which microbial life can exist is 122 degrees Celsius, and it is likely that the limit of life in the deep biosphere is defined by temperature rather than absolute depth. Our biosphere is divided into a number of biomes, inhabited by fairly similar flora and fauna. On land, biomes are separated primarily by latitude. Terrestrial biomes lying within the Arctic and Antarctic circles are relatively barren of plant and animal life, while most of the more populous biomes lie near the equator. Terrestrial organisms in temperate and Arctic biomes have relatively small amounts of total biomass, smaller energy requirements, and display prominent adaptations to cold, including world-spanning migrations, social adaptations, homeothermy, estivation and multiple layers of insulation. Specific biospheres. For this list, if a word is followed by a number, it is usually referring to a specific system or number. Thus, Biosphere 1, the planet Earth. Biosphere 2, laboratory in Arizona, United States, which contains 3.15 acres of closed ecosystem. Bios 3, a closed ecosystem at the Institute of Biophysics in Krasnoyarsk, Siberia, in what was then the Soviet Union. Biosphere J, an experiment in Japan. Extraterrestrial biospheres. No biospheres have been detected beyond the Earth, therefore, the existence of extraterrestrial biospheres remains hypothetical. The rare Earth hypothesis suggests they should be very rare, save ones composed of microbial life only. On the other hand, Earth analogues may be quite numerous, at least in the Milky Way galaxy. Given limited understanding of abiogenesis, it is currently unknown what percentage of these planets actually develop biospheres. It is also possible that artificial biospheres will be created during the future, for example on Mars. The process of creating an uncontained system that mimics the function of Earth's biosphere is called terraforming.